Let's talk about wave soaring and gliders. In wave soaring, we will fly on rising air within mountain waves, also called lee waves or standing gravity waves. In the typical wave profile, the air flows down from a drop in terrain, bounces up, downwind of the drop-off, and can repeat itself several times. This can also induce a rotating motion below called a rotor. This action sets up bands of sinking and rising air that remain stationary in relation to the terrain. Lenticular clouds often form in the area of the rising air and at its crest. These clouds are stationary even though the wind speeds can be quite high. So, why go wave soaring? For one, it lets us reach high altitudes such as the 5,000 meter or 16,404 foot gain required for a diamond badge. It can also allow us to go long distances, often without turning. It can be a way to go really high and start for a long glide, or a high-speed run following a line of lift. This video will not qualify you for wave soaring. Proper training, equipment, and preparation are required, including oxygen, warm clothing, it can get very cold, radio, transponder or ADS-B, weather planning, dealing with ATC including pre-approval for entry into Class A airspace, and a plan. Wave flying requires specific conditions for waves to form. Terrain with a drop-off on the downwind side. Interestingly, it's the drop-off that causes the wave to form, not any upslope on the upwind side. Wind within about 30 degrees perpendicular to the terrain, and at least 15 to 20 knots at ridgetop and increasing with altitude. A stable temperature lapse rate, that is, when looking at a skew-T plot, the actual temperature gradient is more vertical than the dry adiabat lines. Forecasting sites such as SkySight can depict lines of wave as illustrated here. Red areas are rising air, and blue areas are sinking air. To enter the wave, you could tow to it. Here we illustrate going around the rotor area and entering the wave lift from the side. In this illustration, different tow strategies entering perpendicular to the wave are illustrated depending on the wind speed. You could also thermal into the wave. However, oftentimes the stable air that generates good wave flying makes for poor thermal conditions. In this illustration, the glider also utilizes the upward motion on the upwind side of the rotor, which can be very turbulent, to climb into the smooth wave flow. Look at this side view of a wave flight. Color-coded by vertical speed, where the yellow indicates climbs, the rising air can often be in a fairly narrow band. Using ground-based landmarks, or even better, a flight computer track, can greatly aid in keeping track of the boundaries of the rising air you discover, and then being able to remain within it. Because wind speeds can be very high, when searching for the lift area, it's a good idea to search upwind first to avoid entering the downward wash or the turbulent rotor zone. The wind speed may easily match the glider's true airspeed. As such, you will need to select a speed and heading that allows you to maneuver within the lift area without being blown downwind into the descending part of the wave or into clouds. Unlike thermal soaring, where we typically fly circles, soaring in wave often utilizes a series of traverses within the narrow rising air band. Here's a top and front view of the same flight. In order to extend into Class A airspace, which in the USA is above 18,000 feet MSL, permission and coordination with ATC is required. You will need a clearance which is almost always associated with a prearranged wave window. You will also need a radio and a transponder and most likely ADS-B out. When considering a high-altitude flight, you must consider the allowable airspeed range of the glider. Remember, VNE, or the never exceed speed, is based on true airspeed, not indicated. The indicated maximum airspeed decreases with altitude due to flutter limitations. If your instrumentation doesn't provide you true airspeed for you, you can estimate it with a rule of thumb that adds 2% per 1,000 feet greater than the indicated airspeed. Thus, at 15,000 feet, it would be about 30% greater than indicated. You'll need to know the high altitude limits for the glider in use. Here's an example of the indicated airspeed limits for various altitudes provided by the manufacturer of this LS3. Wave flying is not without its hazards, which is another reason why proper training is required before attempting it. Hazards include being caught on top, being blown or caught downwind, rotor, hypothermia, and hypoxia. So wave flying often takes us above the clouds. You could get caught on top if the clouds gaps close, and they can do that rather quickly. You could get blown or caught downwind of the airport, unable to penetrate high winds going home upwind. Note the forecast winds in this illustration. A 65-knot headwind home requires a plan. You could encounter rotor with strong downdrafts and potentially severe turbulence. The book Exploring the Monster details the research team investigating the Sierra Mountain Wave around 1950. These guys were prepared, and still they encountered rotor with over 15 Gs per experience and broke one of their gliders into 3 parts. It might be 90 degrees on the ground, but shorts and well-ventilated sneakers are not adequate clothing for high-altitude flights. It can be well below freezing at these altitudes, leading to hypothermia and frost forming on the canopies. These same cold temperatures can be hard on glider gel coat finishes if they are warmed back up too quickly. Additionally, freezing of any water that had accumulated in places like the spoiler box may lead to the necessity of a no-spoiler approach. Hypoxia is a threat if the proper oxygen equipment is not installed, used, and properly functioning. Follow manufacturer's recommendations for the limitations when a mask versus cannula is needed, and monitor your oxygen saturation with a portable pulse oximeter. Some common errors: poor speed control while in the rotor turbulence, failure to maintain proper speed in areas of lift in order to remain in the lift, rough control technique, poor division of attention, losing track of where you are in the wave pattern, poor control coordination and planning in order to stay in the lift area, not scanning for other traffic, and not having the proper training or equipment for high altitude flights. With those in mind, wave soaring is fun, has a great view, can be challenging, and rewarding. At my home glider port, they call the Wave Day means that one of the best soaring days of the year is potentially at hand. Attending a wave camp is a great way to be properly trained and to meet these challenges and rewards, and it'll help make you a better soaring pilot. Safe soaring! Thanks for watching.